So we're going to talk about logarithmic functions, and by definition you can see here that this is the logarithmic form and it's equivalent to the exponential form. So the first thing we're going to do is practice going from logarithmic to exponential and then vice versa. So then we'll take it back from exponential to logarithmic form. Okay, so if this is an exponential form, which is in likeness of this, we can see that this is the x is here, and then the a raised to some exponent, so this is a, y is there. So we can see that x is 342, y is the 3, the a represents the 7, and so now we need to put it in this format over here. So if I write it underneath, y is equal to log a of x. All I'm going to do is copy this here and now plug in these values into this format. So that's going to be the y is what? 3. 3 is equal to log. The base a is 7 and x is 342. So let me move these out from underneath so you could see we went from this exponential form and put it into logarithmic form by converting it over. Okay, so this next one for b, we're going to take it from logarithmic form and put it in exponential form. And I'll try to leave this part up here showing just so you can refer back to it. But what I like to do is I like to see it by process. So it's going to be this raised to this. So it's going to be 1/2 raised to the negative third power equals 8. So I want you to watch that. It's going to be this raised to this equals this. So when we take it from logarithmic to exponential, we can see that happen, and that's actually the way that I prefer to do it. It's most comfortable to me. So I'm going to skip down to D and then F. So let's do all these while we're in likeness of thinking right now. So for D, we're going to say 5 raised to the negative 3 is equal to 1 over 125. So from logarithmic to exponential, we can kind of see a little bit of a pattern going there. So this one is going to be 8 raised to the 0 is equal to 1. So that would be 8 raised to the 0 is equal to 1. Okay, so with that in mind, let's jump back up to C. Now I know I'm going to be having a log. I'm going to go from exponential to logarithm. I'm going to have a log base something of this is equal to some other. Now, we said this number raised to this number is going to equal this number. So 10 raised to the 4th power equals 10,000. Okay, so then we test ourselves. This raised to this equals this. And that's going to be correct. Now let's do the same thing for E. I'll say log of some base, log base something is equal to some other number. So it's going to be 8 raised to the 1st power equals 8. So according to a power, we say 8 raised to the 1st power equals 8. So this raised to this equals this. So 8 to the 1st power equals 8. So 8 to the 1st power equals 8 one more time. And like I said, or you can memorize the formulas up here and put them in place and label, kind of like we did with A. But most people end up being very comfortable with the pattern and changing back and forth from logarithmic to exponential and vice versa. Now we're going to solve each equation using the properties. So because this is in logarithmic form, I'm going to change it to exponential, and I'm going to say x raised to the third equals this. So when I write that out, I will get x to the third power, so this raised to this equals 27 over 64. So if I was to solve this for x, I could take the cubed root of both sides. So cube this side, the cube root, and I would get what times what times what gives me x. And then the cube root of 27 is 3, and the cubed root of 64 is 4, so we find out that x is equal to 3/4. And just to clarify that, that's because 27 is 3 times 3 times 3. 64 is this, so that's why it would simplify to 3/4. Alright, let's move to number 2. Log base 4 of x is equal to 3/2, so we're going to say 4 raised to the 3/2 power is equal to x. And then we could simply put that in the calculator. I would suggest that you put parentheses in there if so. Also, if we broke that down and rewrote this fractional exponent as a radical, we would have this. Or let's go ahead and move our exponent to the outside. That'll be a little bit easier to simplify this to the third power. So this is the square root of 4 is 2, and then 2 cubed means 2 times 2 times 2, which is 8. Like I said, you have a calculator and you're able to calculate that just from up here. But if you wanted to take the practice of breaking it down into radicals, you can continue on as we finished and still get 8. Alright, and let's look at number 3. Alright, so we have 8 raised to the x, so I'm going to go ahead and write that down. 8 raised to the x is equal to, which that's the same thing as 8 to the 1/4 power. You can rewrite radicals as fractional exponents, and that's the same thing. Now, when the bases match, 8 equals 8, we can then just say x is equal to 1/4. Set the exponents equal to one another, and we have x equals 1/4. Okay, so let's look a little more precisely at a logarithmic function in the graph of that. So if our function f of x is equal to the log base a of x, that's going to be our definition. We come here and we say, suppose our function is log base b of x. Okay, the domain, which is your x values, is going to be from 0 to infinity. The range is your y values, and it's from negative infinity to positive infinity. Important is 1, 0 is always on the graph, and there is a vertical asymptote at x equals 0. Okay, so those are two things that's going to be standard. This point's important to you. It's the point 1, 0, which in this case is here, and in this case is here. So we can see on either graph 1, 0 is going to be included. It's 1-to-1 and continuous. If b is greater than 1, that means if this little number right here is bigger than 1, your graph is going to have this shape. It's a parent graph. But if this number right here is anything between 0 and 1, like 0, 1/2, 1/4, some fraction. If it's some fraction between 0 and 1, you have a different graph, and it looks like this. So these are parent graphs, and the only reason we have 2 is because we have when the b right here, the log base b, is greater than 1, we have this. When it's in between 0 and 1, we have this case right here. And we'll get better at this as we go.